This is TWIS, This Week in Science, episode number 1061, recorded on June 3rd, 2026. Science needs you. Hey everyone, I am Dr. Kiki, and tonight on the show, we are going to fill your head with rules, training, and liver navigating. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience. Disclaimer, disclaimer, disclaimer! The proposal has been submitted. So many hours we thought it through. We understand it might not land, and although our aims were true, yet an itch won't let me rest, even though we tried our best to explain the idea, the methods, and evaluative schemes. It's possible our words won't screen. Did we mention diversity, or was it all American citizenry? We're blessed, I guess, not to study sex, but rather the homogeneity of science-ishness. And what if we win an award? What will happen then? Will the money come through? Will the effort be allowed to pursue all the things that it wants to do, or will this dream be pulled down the drain? We propose you listen to This Week in Science coming up next.
I've got the kind of mind that can't get enough. I wanna learn everything. I wanna fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I wanna know what's happening, what's happening, what's happening this week in science. What's happening, what's happening, what's happening this week in science.
Good science to you, Kiki.
And a good science to you too, Blair, and everyone out there. Welcome to another episode of This Week in Science. We are back again to talk about all the cool sciencey things that happened in the last week. Did you have a good week, Blair?
Oh, yeah. How about you?
Oh, yeah.
You know, just gotta ignore everything going on outside of your immediate life and family. And then it's all fine. It's all good.
Yes.
You can't look. Don't look out.
Think local.
Yeah.
Just think
Then
local.
it's fine.
That is fine.
Yeah, unless you live in an area that was recently gerrymandered, then it's not fine if you're having a primary. But you know what? It's all good. We're going to move forward.
We did
We're all
have
going to
a voting
exercise
day, right?
our
Yes.
civil rights.
I hope
And
everyone who wanted to was able to, has
yeah.
been able to exercise their civil rights. Oh boy, what a time to be alive. And the disclaimer for today was a little bit based on personal experience, and we'll get to that in just a moment with our science news. So,
Nice.
yeah, I have stories, oh yeah, about new rules
Oh.
that might have to do with government grants, and also bad food quality, bad gut sequencing, bowerbird bonanzas, and an octopus mirror attack.
What? Kiki's Animal Corner.
I know! I saw the
I'm
stories and
very
I just couldn't not. I
excited.
love the animals. What is
That's
in
great.
Blair's Animal Corner?
I have DEET. It's always good to have around in certain areas and certain times of the year.
This time of year in the
mhm.
Northern Hemisphere, very much so.
Yeah, and then I have some wild pigs, and I have pigeon navigation back in the chat.
We love the pigeon navigation. But how many wild pigs is it? What was it from Twitter? It was like 52 wild pigs or something.
What's this? I don't know what that is.
It was an old enjoyable Twitter meme about wild pigs. Yes. So there was a certain number of wild pigs that became the number that we needed to have. But this all sounds very
30 to
exciting.
50.
30 to 50 wild boar. Yes. We all need 30
Yes,
to 50.
legitimate question for rural Americans. How do I kill 30 to 50 feral hogs that run into my yard?
Yes. It began an entire conversation. Oh, I loved it. Yeah, so anyway,
Hi.
wild pigs, feral hogs,
Mm-hmm.
one and the same. But now it's time. Are we ready? We're going to jump into the
Yes,
show
let's do it.
without any more ado. I want to remind you that subscribing to the TWIS podcast is the best way for you to get TWIS in your ears every single week when we publish a podcast. Make sure you go to your favorite podcast source and look for This Week in Science and subscribe, and get your friends to subscribe as well. Additionally, if you would like to watch in video, or you like putting the video on and listening for your ears, whatever it is, we are on YouTube, Facebook, and Twitch. We broadcast live weekly Wednesdays, 8 p.m. Pacific time ish, right around there. And you can go to our website, twis.org, to find out more information about every show, our show notes, links to stories, and links to our Patreon community and our Zazzle store. Woo, all the things. Okay.
Mm-hmm.
As usual, you ready to dive in?
Yes.
Okay. We're going to rip the Band-Aid off, and we're going to do the painful thing first. Okay.
Okay. Yeah.
Okay.
Then we can talk about the pigs and the octopus. And
Yeah.
Yeah. Okay.
And then we can have all the fun.
Give me my medicine first. Let's hear it.
This is it for everyone. I do really think it's important to keep everyone apprised of what is happening in the national policy sector with regard to science and research and development.
Yeah.
And so the big news this last week is Russell Vought from the Office of Management and Budget, the OMB, which, if anyone saw my social media posts over the week, I was being quick and easy, and my dad texted me and said, "What do you mean? OMB, EO, no jargon." And he was giving me trouble. So I'm explaining myself here. I don't like typing with my thumbs, and also, character limits, and just not wanting to take the time to write everything out in social media for me. But OMB, the Office of Management and Budget, Russell Vought is the director of that office. This last week, he submitted new rules for the Office of Management and Budget with specific implications for a part of the how we fund grants in the United States. And so there is a specific part of the Code of Federal Regulations, the CFR. And if you ever apply for a grant, which I just did, I just submitted my very first NSF grant as a PI, which is very exciting. I don't know why I did it, just to feel the pain, maybe. But there's a lot that goes into those grants. So for everyone who has had to do these forever to try and get funding, yeah, I understand. It's a lot. And to suddenly have your funding pulled away from you capriciously by politicians, it's not just harmful to the science. It dismisses the time and the expertise and the effort that is gone through to procure the funds to make sure that we can properly fund basic science research and eventual development into applications, technologies, applications, etc. Okay, so the proposal from the OMB was new guidance for the federal financial assistance located in Title II of the CFR. And within this change, they initially, in their summary, say, we are doing this, one, to improve transparency, accountability, and oversight for use of federal taxpayer dollars. Two, to clarify status of OMB's policies and requirements set forth in the Code of Federal Regulations, text as an OMB regulation. And three, reduce recipient burden. All of these things, great. It's amazing. And the last time there were changes was just very recently, actually 2 years ago in 2004. And part of the reasoning in that was to streamline processes and to reduce recipient burdens so that the process of applying is actually easier. The process of managing the money is easier. All of the regulatory burdens are reduced so that um, the the principal investigators or people who are principal on the grants can actually do the work as opposed to having to work as hard. So, but anyway, they're still working on it, obviously. That's great. And you read through the initial summary of the grants and federal financial assistance and where the money goes. And while people online have been talking about this specifically impacting science, this applies across all regulatory agencies across the government. So any grant making organization, any organization, agency within the federal government that gives federal assistance in any way, the small business grants to food, to housing shelters, like everything is now, if these rules go through, because they're proposed, if they are accepted, this will in effect proceduralize the executive orders, the EOs, that Trump has been proclaiming over the last year. So several of the executive orders are institutionalized and proceduralized within these proposed regulations for the OMB. And among those are allowing political appointees to be the only people who review grants and decide who gets the money. In the case of scientific peer review, those political appointees, that peer review can still happen. Those political appointees just don't need to look at it or pay attention to it. It's not important.
Course. Why would they want to do that?
Yeah. Why would they? This is a 300-page document, something like that. It's an 412-page document. It is extensive in terms of the rules and regulations that it proposes. But in effect, what it is doing is removing peer review. It is removing scientific evidence and allowing politics to take over. So in addition to the giving of the grants and how the grants are decided, that process, while currently what happens, any government agency that wants to give out federal assistance, they notify the public with a solicitation. That solicitation has all the rules and tells everybody what to do. And then there's a fair and free submission process for asking for the money. They have suggested that, they might not always need to do that, and that there might be private solicitations that are not actually publicly announced.
Mm-hmm.
So that the whole transparency and accountability issue, right there, they're shooting themselves in the foot, because basically they said, we might not actually we'll give grants out, but we might just decide who to give them to without actually asking the public if they would like to be a part of getting some of the money that they gave to the government. And then further, they say that at any point, they could just take the grant money away. That if not just the grantees, the people who have gotten the funding, but the institutions that they're affiliated with and even collaborators that they are working with, if any of those parties are found to be working against the administration's aims, then they can take the money away to be paid back by the grantee at any point in time.
This is wild.
Yeah, it is. It's so for the last year, we've been talking about, oh my gosh, can Trump do this? Can the executive orders actually put this forward? Can this happen? What they have done is they role played last year. They tried to take money away. They saw what Congress did. They tried to do what they could. And now they are trying to operationalize it and put it into the regulatory doctrine.
I don't know. I think, I wonder the same thing I always wonder about these dystopian policies that they keep enacting, which is like, I have no concerns that most of these are going to get turned back around, but what will we have lost?
Mm-hmm.
How long will it take to fix? It's just, I think that's the part that's really scary to me, is like, I can get through these tough times now, but how long are the ramifications of this nonsense going to permeate through our entire existence? Like, everything that they're doing. I mean, if you want to talk about withdrawing funding, I was just learning today about how they're talking about the Department of Education is talking about holding colleges and universities accountable for low earning outcomes. So basically, like, anybody in the arts, like anybody teaching people the arts is going to lose funding. Like, just and I understand it. Let's talk meta here, like the real
earning outcomes, like
the real output here that they are playing for is ignorance. That is the goal, right? And I don't quite understand, like, at least for this that you're talking about, like the grants, like, that's the ignorance there, and the loss of knowledge is probably a happy byproduct. Really what they're trying to do is funnel government money to their friends. Like, that's really what this is about.
And that's what I'll agree with. And so there has been, sensationalism. I mean, this is the time, and I have agreed with people online, this is the time for people who appreciate science to really, like, rattle the cage. And currently, until July 13th, they are accepting comments on this proposed regulation, these proposed rules. And so there are many places that you can go. I've shared links on LinkedIn, and there are many articles available online that share templates and ideas for writing commentary and giving your feedback on these proposed rules. And so, like you mentioned, voting earlier, this is, even though it's not voting, by making our voices heard, by ensuring that our comments are delivered, then we at some point, even if they do accept these, at some point, if we can come back with courts, if there's evidence that the people were not in support of this change and that it was taken unilaterally. So there are places that you can go. Stand Up for Science is a great organization who is working to advocate for science in this time of massive chaos. I don't agree. They have a template available and a way for you to submit your comments so that your comment is recorded through their systems, because apparently there's been problems with the whitehouse.gov site, and like comments are getting lost or not going through. And so they are suggesting that by using an external system like theirs and other organizations that are involved in this, that your commentary can be delivered still, just not, and it won't be hampered by, misacting, misbehaving White House technology.
Goodness.
The other side to this, though, is the way that it's being talked about. And there is a bit of hyperbole, especially on the side of groups like Stand Up for Science, where this is a big deal. This is one of the ones where this is not just an executive order. This is being put into policy. And so this is one of the times when we need to get the word out, when people need to stand up and do something. And they are right that we need to be telling people about it and getting action taken. However, the way that they're saying it is that this is going to, there will be no more funding for science. There will be no more grants. There will be no more this. And that's not actually true. Exactly what you said, Blair. There is going to be a rerouting of funding. There's billions of dollars in the government.
Yeah.
The funding is not going anywhere. It's just, where is it going?
Who's going to get it? Yeah.
Who is going to get it? How justified are those awards? Additionally, are they doing interesting things that are novel, or are they simply pandering to an administration? There are some, very interesting I think communications points that need to be brought up here, that there are many arguments to be made that the system within the government for granting financial help it's broken. There's so much, like, I just did it. It was so hard. It was so much, and it takes so much time, but these are the things. How can we fix it in a way that's actually sustainable and good for society,
Hmm.
right? As opposed to a new funnel.
Mm-hmm.
So, anyway.
Yeah, I mean, and I'll similar to what I was saying before, like, how is the path back to normalcy going to be forged after this? Like, are you going to try to work within the new confines and slowly broaden those confines? Are you going to try to, like, change the way that you apply to grants to fulfill the expectation to get the resources and then do whatever you're going to do anyway? Or are we going to lose fields? I don't know.
I think it's a combination of all these things. I mean, there's no one or the other. I think it's a yes and. This is there have over the last year, we've lost over 10,000 people from federal science. And that's the very low end of the losses. That's not including the graduate students who are no longer going to graduate school, the programs that have stopped accepting graduate students because they don't have the funding, researchers like you're mentioning who are no longer pursuing lines of research because they can't get the funding. The federal government does fund the bulk of basic research in the United States. It is not the kind of thing that can just be given over to venture capital or, private equity. The way that corporate America and the economics of the stock market and investing work it's not the same. There needs to be funding that it's from the people to search for new answers and new directions that then might lead to the things that investors are ready for and want.
Well, not to mention that if all new scientific discoveries come from for-profit companies, then everything is going to be trademarked or patented and will not be available to people except for a lot of money. That's why the federal government pays for scientific research. It keeps us all healthy. It keeps prices of things that everyone needs low or lower.
The common good. There's something to be said for it.
We, as taxpayers, we are providing the funding for these things. And so I think that's the part that's like the most morally reprehensible to me, is that these are decisions that are being made unilaterally for how to spend my money, your money, our money. This is not, some venture capitalist who's like, I only want to fund things that follow my ideologies. No, it's our money.
And this question from the chat, Radius is asking, how fast are they changing? Do you get to have discussion in the public, or are they changing money faster than people can stop? And for these grants, for the scientific grants that have been unfunded, for the way that they are deciding to shift funding priorities, it is happening very fast. And although they are following the letter of the law with the opportunity for commentary, right now there's not a lot of there aren't that many ways for individuals, researchers, universities to be able to say, hey, wait, why'd you do that? And so there are many people who are keeping records of who's losing what money, where, how much money is being lost. There are efforts underway to document the devastation of what is happening to science right now. And many things are, and Kevin is saying, as fast as email travels. And that's pretty much it, because sometimes there's no expectation of losing money, and then an email is sent in the middle of the night and the next day,
Mm-hmm.
somebody no longer has money and their entire research program is done. And maybe that research program was in the middle of a 10-year data collection, right?
Mm-hmm.
Maybe it got in the way of some major effort. So there's a lot changing without a lot of discussion. And as much as people are shouting about it, the thing is it's legal routes in the future, but those are slow. And that's what we've
Mm-hmm.
got.
Yeah, I mean, we're
So
really learning
how our
how
government works
much. Well,
or
I was going to
doesn't.
say specifically, like, how much of our government worked on common decency.
Yeah.
So much of it was just like, oh, but you'd never. That's uncouth. Like, you can't. And then just everyone's like, what are you going to do? Try to stop me? You can't stop me. There's no rule.
Mm-hmm.
And here we are.
Yep. It was gentlemen's agreements. A lot of just this is
Yeah.
the way it's done, but there was nothing written down.
Mhm.
And so
Yeah.
that's where we are. Yeah.
Yep.
Oh, but science, it is not going to end. It will never end. Science is going to continue in various formats within the United States, no matter what. There's always going to be amazing news. There's always going to be science globally being pursued for the human benefit, as opposed to some nationalist pride. And I do see that as something that brings me optimism. That science itself might we're going over a very big stumbling block in the United States, but it doesn't mean the end of science, you know. And as you said, Blair, it might be hard, but we'll build back, as soon as we get the chance.
Yeah.
But along those lines, yeah, if you want to say something, you should. July 13th is the deadline for commenting, and I shared a link in our chat, and I will share a link on our website, so anyone who is so inclined can make a comment about these proposed rules. Moving on from proposed rules, what about oh wait, what? I feel like it's from bloodsucker to bloodsucker, Blair.
Yeah. So any of us that have used DEET in the past to keep mosquitoes away, you might be training them to look for DEET to bite.
How so? What up?
Well, this is a study out of Journal of Experimental Biology. It was a collaboration between some associate professors at Virginia Tech and University of Tours in France. And so the idea, the thing that they wanted to look at was, hypothetically, if someone applies DEET and the concentration fades over time, and so eventually a mosquito manages to feed, could they then associate the smell of DEET with a feeding reward? So, to test this,
though the DEET is bad for them.
Yes.
Generally.
Yes,
Yeah.
They looked at the yellow fever mosquito, Aedes aegypti, which they carry dengue fever, Zika, yellow fever, and lots of other kind of terrible diseases that infect tens of millions of people every year. They train the mosquitoes. This already sounds like a bad idea, but whatever. They train the mosquitoes using a form of Pavlovian conditioning. And so they restrained the mosquitoes behind fabric mesh with a bag of warm blood positioned just out of reach. After the mosquitoes began to feed on the blood, researchers then introduced the smell of DEET. And after repeating the experiment 4 times, more than 60% of the insects tried to feed when presented only with the smell of DEET. Then they were given a choice between 2 human hands, one untreated and one coated with DEET at normal concentrations. Untrained mosquitoes avoided DEET. The trained mosquitoes went right to it. They were drawn to the DEET-treated hand. They also found that mosquitoes could form the same association with sugar instead of blood used as a reward. So it wasn't just the blood. The assumption is previously that the repellents work because of the chemistry. DEET smells bad to mosquitoes, they flee, and the chemistry prevents them from smelling us through the DEET. But what they're showing is there's plasticity in the mosquito's brain. So basically they could rewrite the response based on experience. So they're saying, okay, we're not saying don't use DEET at all. What they are saying, because it saves lives, okay, especially if you're going into one of these areas that has these deadly diseases.
And
however,
increasingly southern areas of the United States because of climate change.
Yes.
Sorry.
But if you are using it, there are some things to consider. Instead of applying a lot all at once, apply regularly so you have a continuous concentration on you, continuous protection. There isn't a moment where the DEET is less strong and then they can jump on you, because not only then they can get past it and get you sick, but you're accidentally conditioning wild mosquitoes to smell out DEET. They also said that part of it could have to do with treating clothing. So I know that that is a really common practice, is to treat your clothing with DEET. But DEET concentrations in fabric decline over time. So if you buy fabric that's supposed to have repellent in it, or if you treat the fabric yourself, similar to your skin, it needs to be treated repeatedly. And there's not really good studies on how often to do that or anything like that. Not to mention that different fabrics have different responses to DEET. Whereas, you know, generally you can say human skin is human skin and the bottle will tell you how often to reapply. But fabric has so many different variables that it's really hard to be consistent with the concentration and the response that the mosquitoes might have. So you could actually be making it worse. So treating yourself, they're saying, is better than treating the fabric. Yeah. So, I mean, they're basically just saying, like, mosquitoes are smarter than we thought. Their opportunity, I know it's like the classic thing, right? But there are opportunities
how long have we been training them, though?
Exactly. I know.
So DEET is supposed to be the best repellent, but have we actually made it the best attractant now?
Right.
Because people have been using it for so long.
Well, and I think there's also, I know, you know, in my experience, people are always saying like, but DEET, like the chemicals are so strong, it's not very good for you. You're not supposed to use it very often. So that's my other thing, is if that's the kind of narrative that you're given, are you not using it enough or often enough? And is that making it worse, right? So that's part of, like, if you're going to do it, do it.
It's
if
like
you're in a place where
sunscreen,
yes,
right?
exactly. Yeah.
Yeah.
Yeah. But the sunscreen isn't going to cause the same problems that treating yourself with DEET is. So you have to, like, so it's like, if the mosquito situation is bad enough that you need to use DEET, then use the DEET. Don't do it halfway. I think the half measures are really what I took out of this. But I also just thought it was funny that mosquitoes can learn, and they used a Pavlovian experiment design to see if they could get through the DEET to the blood.
Pavlov's vampires.
Yes, exactly.
Instead of just Pavlov's dogs. Pavlov's blood-sucking mosquitoes.
Yeah.
Oh my gosh. But now I wonder about so many things. Like, people have talked forever about Avon's Skin So Soft being another one of like the weird natural repellents. You know,
Skin So Soft is a repellent?
I think it was Skin So Soft. Am I wrong, everybody in the chat?
I don't know.
I think that's the one.
I only
but
ever
it's like
used Skin So Soft for one thing in my whole life, and that was conditioning opossum ears and toes. So I have no reference for that at all.
This is coming out of some deep memory bed in here, so I might have gotten it wrong, but I believe that's what it is. But are you looking it up?
Yes, I am. Well, the classic Avon Skin So Soft bath oil is a popular home remedy. It is not an EPA-registered mosquito repellent.
But it is one that has been scientifically shown as a repellent. And it's...
Mosquitoes hate the smell and taste.
Yep.
Wow.
But I wonder if they hate the smell and the taste. You know how they have, like, the bitter stuff that tastes like weird bananas or smells like weird bananas to stop you from biting your fingernails?
Oh, sure, yes. Yeah.
It's supposed to be that operant conditioning, right?
Uh-huh.
Or the taste conditioning, to repel you from that thing. And so if you think people are going to if they smell like Skin So Soft or like DEET, wouldn't it potentially have that opposite effect if it tastes bad as well because of taste conditioning?
Yeah, could be.
Yeah.
Absolutely. I mean, if you
But
had
anyway,
that stuff on your
learn.
fingernails long enough,
You learn
that
to like it.
yeah, the taste of that might have a calming effect on your nervous system.
It's true.
Yeah.
It's
Interesting. All right. Well,
Anyway,
speaking of
mosquitoes, they're just like us.
delicious food, delicious tastes.
Do you want me to go on to delicious tastes?
Yes.
Yeah, so I've got a couple of stories related to badness. It's so bad. It's so bad. But it's good.
It's so bad it's good.
Yeah, or it's really, really bad, but it's maybe not so bad for this first story. I don't know. Ultra processed foods. We've been hearing all this news about ultra processed foods are killing us. Ultra processed foods are the things that are worst in the world in our diets. And, oh my God, how could anyone eat ultra processed foods? That said, and I've had this thought as we've talked about it before, is that ultra processed foods, there's a gamut, right? There's a wide spectrum of what an ultra processed food is.
Yeah.
You can have a sausage that's made with very, very, very good ingredients, or you can have a sausage made with really, 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 really bad ingredients. Are they the same in terms of their ultra processedness and being bad for you? So these researchers looked at this question, and they looked at the question of, for these ultra processed foods, if we adjust and manage the sugar, the fats, the things that are nutrients but bad, if we manage those things, how does the impact of the ultra processed food actually change? What do you think happened, Blair?
I don't know.
Thanks for playing.
I'm sorry.
It's fine.
Tell me.
Okay, so what they discovered is that basically there are differences between different kinds of ultra processed foods, and
Yes.
that the impact of ultra processed foods is not explained by the content of nutrient factors. So it's how it's made. It's how the cellular structure of whatever the food was disrupted. It's the other additives and things that are there. But when they controlled for fat, sugar, or sodium, they saw that there was very little effect.
What?
Yeah. So it's not just that ultra processed foods have more fat, have more sodium, have more
Oh.
sugar. That is not the only thing. Yes, when they took sodium out, it was better for people. Yes, but it didn't explain the entire difference in health impacts of ultra processed foods. And so what this study is suggesting is that the all-cause mortality is more likely to be related to other components of the food being ultra processed. So you've got things like additives,
Preservatives.
processing,
Yeah.
right? Extra chemicals that are added. And so in their analysis, they looked at a whole bunch of different variables. They looked at ultra processed foods and risk factors, UPFs and mortality, food subgroups that they were looking at, and they looked at the impact of all these things on the individuals through the time of the study. And one of the things that they saw that they thought was very interesting, and that is something that is worth more study, The same or ultra processed food eaten by people in low income groups is more likely to lead to worse health outcomes than the ultra processed food eaten by individuals in high income groups.
Yeah.
The
Yeah.
other side of that is really, what is the ultra processed food that you're buying at a higher end grocery store?
Mhm.
What are the ingredients and processes involved in that food versus the ultra processed food that you're buying at a budget discount store?
Well, but also, like, are you buying processed foods because you live in a food desert?
There's that. Yes, that as
Or
well.
do you
So
live
how
right
much of
next to
your
a farmer's
diet.
market? So you're
Yeah,
going to eat your
yeah.
ultra processed food as a treat, but then you're going to have your fresh fruit and vegetables tomorrow.
Mhm.
I think that's part of it too, is like, i- you're not often having like a whole spread of wonderful whole fruits and veggies alongside your ultra processed food too, right? So like there's not a lot of
That's
pairing.
right?
So that also means if you're eating the ultra processed food, like that's your meal. Your meal is the processed food. It's not, I'm going to have some french fries and then I'm also going to have a salad with like grilled chicken on top. Like people do
Mm.
that, but generally that's not how ultra processed food works. I also wonder if part of it has to do with the pure volume, because a lot of ultra processed food is addictive.
Mhm. And a lot of it is preserved. So, no current states, according to this study, have included nitrite preservatives as part of ultra processed food definitions. Nitrites are widely used in processed meats. And processed meats are usually more associated with the higher blood pressure, BMI,
Mhm.
etc. Um, There also one thing I think that is really interesting here, they say our new findings support the need to consider ultra-processed foods separately from traditional or conventional nutritional criteria.
Mm.
Like,
Mhm.
basically, they're saying ultra-processed foods, we shouldn't count them as food anymore. We can't look at it in the same way as we look at regular food
Right.
'cause
Yeah.
because of the
It's
additives,
a
because of
separate food
everything.
group, basically.
They did the way they said it is like, it doesn't count. We can't it
Wow.
doesn't go with conventional food. It's not food.
So Kevin Reardon has a really good question in the chat. Has anyone defined ultra processed food? So like what does that mean as
Mhm.
opposed to just
Yes.
normal processed food?
Yes, so it is defined, and let me see if I can, uh it is defined, yes, but I am
Okay.
not saying I don't have the definition right in front of me at the moment, so let me see what I can do on finding that. Um, but there is a definition as to, it's not just bread, I
Mhm.
think. Okay, so ultra processed foods are characterized by industrial processes and additives uncommon in home cooking that alter shelf life, flavor, texture, fat content, or production costs.
So what's normal processed foods?
Right. So, you can have pasta, which is
I see.
processed
I
in
see.
the
Yes.
it's dried, it
Yeah.
has a stable shelf life, but it hasn't been like there are some pastas that are ultra processed because they have had additives
Mhm.
put in them to ensure that they will be shelf stable for longer or to, put other things in them for
Right.
dietary
So
factors.
we're talking about bread from the bakery versus, no shade, um, like Pillsbury crescent rolls.
Right.
The ingredient list is a little different.
Right, but, like, even those Pillsbury crescent rolls, if you are buying them in the you bake it yourself kind of way, it's not gonna be as highly processed as some crescent rolls that you buy in a box on the
Right.
counter that
Right.
are gonna sit on your counter and not mold
Right.
for 3 or 4 weeks. That's a big question.
Interesting.
Yeah, so it's the idea of the ultra processed food are the ones where, it we have created sausages and meats to preserve meat, for a very long time. but some of the ways that those processes happen are more intensive than others. But yeah, I think that it's vague, and I think that in itself is very difficult. But it's, I think, a very interesting question. And I don't know, the big point here of that they brought up, like maybe we should look at it completely different from how we look at food. maybe it's maybe it's not the same as conventional food at
Yeah.
all.
Yeah.
Yeah.
I mean, I don't even know how that would work. Like, basically, it's ultra processed food. It's like not even, it's like a lollipop. Like, the nutritional value is negative.
Right, but like that's the thing that they were saying is that it's not always just totally negative. It's just that there are these other factors that we do not understand that have made the food negative. Where if you have the same ingredients, just without all of those other factors, it's actually a fine food. That the nutrients,
Right.
they work.
Right.
Yeah.
So
So
what do we do with this information? Just don't eat the ultra processed food.
I
Easy
mean,
for
it's
some than others.
yeah, easier for some than others, and that, like you mentioned, food deserts. It's impossible for some people to be able to manage,
Yeah.
to get away from them, and it that in itself that's a social problem. That's our
Yeah.
society not taking
Yeah.
care of ourselves, and um, yeah, I mean, sometimes you look at different problems and it's like, well, symptom, not cause. Um, and I bet a lot of people, if they could have healthier ultra processed food, they'd be totally happy with it. Or if they could eat less of it, they'd be happy with it, you know?
I would just like it
If you have
if my FDA actually gave a toot about my health, and it doesn't have to be no processed, it doesn't have to be no chemicals, but I would love to have
no.
more expectations for managing what goes on the shelves in the grocery store, because generally speaking, I think I speak for most people when I assume if I see a food on a shelf, I assume it is fine for me to eat it.
Right? It's being sold,
That
right?
is
But
the
this is
point of my government, is to
no,
make
it's a
sure that
free
people aren't
country.
selling me poison.
No, people should be free to sell poison. No, I'm kidding. I didn't mean to say that. I mean, that's not what I mean. But there are people who believe that the freedom should be not just in the choice of the product, but in the ability to have a business and sell whatever product. Um, and so I think there's a balance, and that is the balancing act that our government, when it comes to public health, has to manage very carefully. Um, what did you say there though that struck me though? You said, um, I lost it. My brain disappears sometimes. But yeah, being able to take oh, there was what I was listening to NPR this morning, and there was an interview with someone who's involved in this work, and there apparently is a it's a time right now when the research, the evidence is in place to suggest that, hey, these ultra processed foods are bad. And there is enough public opinion saying we don't want to eat the bad food. We want to be healthy.
Yeah.
And there's federal, like there's policymakers who want to do the work to help. And so there seems to be a time right now where perhaps we'll see ultra processed foods or ingredients in ultra processed foods being regulated more carefully or judiciously for public health. And so that is the
Yeah.
big question.
Yeah.
Is it going to be, oh no, you can't buy your sugar pop bomb donut thing because it just is a full food that's ultra processed, or it has 3 ingredients that we no longer accept?
Yeah.
Right? So
Yeah.
there's, how is that
We
gonna
did
work?
make food before without all these ingredients, is all I'm saying.
And we still do now. It's just so hard to find.
I think that's
It's
my
like,
frustration,
oh my
is like,
gosh.
there's so many, like, I can't even tell you the number of foods I've eaten recently where I've tasted it and gone, this tastes different. And I look at the label and all of a sudden there's all these new multi-syllable chemicals that weren't in there before, instead of just chocolate or something like that, right? And you're like, oh, no wonder this tastes weird. I guess I'm not going to buy this anymore. And it's like exhausting because a lot of the time it feels like a cost saving measure because they can create things in more bulk because they're more shelf
Mhm.
stable or because they're just plain cheaper than the real thing.
And that is something that actually recently happened in a chocolate candy product that a company had where, the family shifted, the ownership shifted, and they decided to do cost saving measures and shifted away from real chocolate to some of these things. People didn't like the flavor, but and now they've backtracked so that they're going back to actually using a real chocolate ingredient again.
Hmm.
Um, and I just wanna, as we always say on this show, just because something has multiple syllable
Right.
chemical
Yes. Yeah.
name, that doesn't mean it's bad. It doesn't mean and sometimes it's just the way that the part of the ingredient is being listed.
Right.
Um, so no shade on the chemical nomenclature within your
No.
ingredient list. It's just how it's used and how it's applied and what's going on there.
Yeah, and just sometimes you have a very simple thing like cane
Mhm.
sugar and it's been replaced by six other things. And I think even just the
Right.
number of ingredients is something that I look at way more than the number of syllables and words. Really good point, Kiki. I think it's the number of ingredients. As I'm looking
Mhm.
for a short list.
Yeah.
Because I shouldn't need to
Unless
buy
it's mole.
something. Yes. I shouldn't need to buy almost anything that is a food product that has more than like 10 ingredients in it. I really shouldn't. Like it
Mhm.
just it's possible, guys. It's possible. We used to do it. It did cost more money to make the food, but I think that's part of this larger conversation too about like profit margins and things like that. That everybody's
Yeah,
just trying to squeeze more and more profit out of everything that they do, and it's just yeah, it's exhausting. It's exhausting being the
exhausting. Consumer.
yeah, you're
Having to pay attention.
you're a consumer, not a customer. It's back to this whole thing again.
Yep.
Is that they're no longer trying to serve us.
Yeah.
We have to consume what they provide. It is a
Yep.
completely different relationship. And it's exhausting.
We could change it if we wanted to.
That'd be great.
Yeah. Okay, so moving on from the bad food quality in the ultra processed foods, let's talk about bad guts.
Yeah,
Research
I have one of those.
A lot of people do, and irritable bowel disease is something that millions of people around the world deal with. Crohn's disease, ulcerative colitis. There's This is chronic inflammation of the GI tract, and according to a press release for about a study from Nature, over 4.9 million people worldwide suffer from irritable bowel disease. And I'm gonna guess it's probably even more than that because you're not even talking about people who've never eaten cheese before. But um, what is it that leads to the irritable bowel? Researchers in Nature just published their study on cell type resolved genetic variation. And so historically, people have gone in, they do a whole body genome assay. They do an assay of the microbes in your stool samples, right? They do a tissue sample, a biopsy from your gut. They've got all these measures that they've done so far to figure out, okay, what is it that's leading to the IBD? What is it that is leading to people having these inflammatory bowels? And for the first time, they were able to do a study where the samples they took were specific to cell types. They were able to map genes across cell types to be able to identify specifically the disorders or the misbehavior of certain cell types in certain situations. So they had what they call EQ2Ls, cis expression quantitative trait loci, across 2.2 million single cells. This was with intestinal biopsies and blood from over 400 people. About 125 of them had IBD. So they're comparing these cells of the IBD suffering people to people who do not have that. And thank you very, very much, Radius. We are humbled by your support. Thank you for being here today. In this study, this is the first time beyond tissue level detection that they have been able to isolate specific cell types at a cellular resolution, what cells are going wrong, when, and why. So the genetic basis of their misbehavior. And so this study is going to allow researchers to be able to highlight different cell types. So dendritic immune cells in the gut versus B cells in the immune system versus secretory cells, mesenchymal cells, different cell populations. What is going on at different places in the gut at different times in relation to what stimuli. And so, as a result of the data that they've gotten, they are able to cross reference across blood, rectum, terminal ileum, these populations of tissues and cell types to be able to identify absolutely um, what cells. And this is getting down to the certain cells, certain immune cells, and they said most often the things that are going wrong are related to the immune system. So these are, like I mentioned, the dendritic cells in the immune system in the gut. Very often are the cells that are misbehaving, getting angry. So what's the genetic basis that leads them to causing more inflammation?
Mm-hmm.
Is it genetic in nature completely, or is it a result of certain, we know the microbiome influences things. So is it
Is
a
it the
certain
ultra processed foods?
right? Isn't it that the crosstalk, the back and forth between,
Yeah.
Between what's going on in the gut and the cells themselves. But this is the what is happening here is it's increasing the resolution at which we will understand where things are going wrong and how to potentially treat them. So they're suggesting, and they have one particular figure in their paper that it's identifying therapeutic repurposing. Oops, I turned off my sharing of screens. Identifying therapeutic repurposing opportunities by co-localization. So they've actually been able to show.
What is this, a Scantron?
It is like a Scantron. You're right. There's all these little bubbles all over the place. But it's showing targets. So interleukin 18 receptor agonist, or let's see, we've got cholinesterases, or which people take drugs for cholinesterases, acetylcholinesterase inhibitor, activator. No, that's not a word.
That's great.
Activator. We've got mucin 1 vaccine antigen. We've got
oh, there's the yep. Now I
got
see the legend at the bottom.
vitamin D receptor agonist. And so we've got the genes that are responsible, the cell types in the tissues, and the disease groups co-localizing so that we can actually begin to specifically target the specific cells that are causing our problems. So,
this is like a master sheet for like a
yes,
lot.
This figure is what I think it's a master sheet for future studies.
Yeah.
Or like you want to go do a clinical study on, how does this impact people's IBD, whatever. I think there is a lot here, and I think it's really exciting because when your gut isn't happy, your body isn't happy, your brain isn't happy. If we could, so many people could be so much happier. It'd be so amazing.
Man, so yeah, we're getting much closer to the just like, hey, it's time for your annual physical. Let's sequence your genome. And then go through and let me know which of these things are bothering you today. And you can be like, great, you're going to do this for this, and you're going to do this for this. And it's going to be like so much more targeted. I'm pretty excited for this piece of future medicine. I think it will be so nice because, you'll really be able to know, well, this particular drug doesn't tend to work on people with this genetic marker, so we're going to use this drug instead. Or even this particular treatment has negative side effects on people with this particular genetic makeup. So let's do something else here. Or, oh, well, all of your symptoms tell us that, you have this one disease, but based on your actual genetics, most likely it's actually this other thing. So, like, it's going to shortcut a lot of medical trial and error.
That used to be trial and error.
Yeah.
Right?
I think that's
Why
the
do we have to
part
go
that's
through
like,
that? Yeah.
so, speaking as someone at the right age in their life where now like things just go wrong with my body and then I have to try to figure it out, right?
Oh, Blair.
So
Blair.
listen, I'm turning 40, all right? Like this is happening now.
You're not allowed to turn 40.
It's happening.
No.
But I know that the medical system, not to like harp on America's ills more, but like the medical system where we
I'm
live,
sure we're gonna like get international audience if we continue to
is such that you not only do you have to be your own advocate, but it is often a long, circuitous path to get the care that you need. And that is not, for lack of trying for medical professionals, but that is the way that you have to navigate the insurance system. But that's also the way that current medical knowledge works. You kind of have to use the obvious choice first. Is the whole like look for horses, not zebras thing, right? So like, you see a very obvious, like, oh, these symptoms usually mean this. You treat that. It doesn't go away. You go to the next thing, right? And so it's just like, it can be really exhausting if you don't have time, money, patience, knowledge to keep going back. Then some things never get fixed. And so if you can have the genetic information to let people know what they're predisposed to, how they might be able to treat various problems, you can cut so much of that down. I'm really excited.
You can cut so much of it down. And I think, the symptoms are one thing, but like you said, the genetic aspect, as we get deeper and deeper into this is where that personalized medicine actually starts coming to a real benefit. Because you suddenly go from your random like 23andMe genetic assay from 15 years ago that said, oh, you have sticky earwax. Like, what am I going to do with that? Okay, whatever. But because of certain single nucleotide polymorphisms, that suddenly, because of research like this, where it's finding single cell correlations between dysfunction and genes, suddenly you have a connection. And so if we can get that information and actually use it in a way where it's not abused by corporations, but actually helpful to individuals, right? Then, I think we're on to something. And you could know whether or not you need a vitamin D supplement versus acetylcholinesterases, right?
There you go.
Yeah.
Yeah.
Yeah. But anyway, the future, I think, is going to be bright. And this study itself found many novel correlations that had never been seen before. So that is in itself
I'm very excited for that.
Incredibly exciting. This is This Week in Science. Thank you so much for joining us for another episode. I hope you are enjoying the show and the stories that we're bringing, the conversation that we're having. And if you're enjoying what we bring to the show this week, please make sure that you're helping to support us. Continue the show, so that we can keep the show going in an ongoing fashion. Make sure we can pay the bills and keep the lights on as we try to talk about science in a human way week after week. We are not recorded. We are not algorithms. We are people who are discussing thoughtfully, compassionately. We have human questions and human ideation. And isn't that something that's good to support in this day and age? Head over to twist.org, click on the Patreon link, become one of our monthly or even annual supporters there. There also is at twist.org a PayPal link if you'd like to donate through PayPal. We also have our Zazzle link if donating isn't your thing, but you'd like a new shirt or mouse pad or towel for your summer beach adventures. Head over to twist.org. That is where your adventure awaits. And of course, sign up for that newsletter that will be coming someday. And now it is time to head on over to that next part of the show that we love to call Blair's Animal Corner.
She loves our creatures, great and small. Biped, millipede, no pet at all. If you want to hear about animals, she's your girl. Except for giant pandas and squirrels. There's Animal Corner.
What you got, Blair?
I have wild pigs.
Wild pigs, 30 to 50 of them.
Yeah. So wild pigs are pretty much universally considered some of the most problematic invasive mammals that you could come across. I know that when I went to New Orleans and I did a swamp tour, I've done one a few times now, and every time they talk
Really?
about how, it's so fun.
That's awesome.
Oh, yes. How the wild pigs are causing these problems. And then I also know that in the park system that I currently work in, we have, I think it's a hybrid of pigs and wild boars that are causing problems in the parks as well. And so it's a very common thread of just like, we got to do something about these pigs. I mean, very similar to the tweet. And so it's generally considered that they're terrible for the environment. They tear up the ground. They create mud holes where there aren't supposed to be them. They just kind of clear cut everything by eating everything. They're kind of foraging in the dirt. So they're moving stuff around, and it's just, they're bad news, right? And so
But
there's
they're
different
cute. And I mean, Princess Mononoke, they're part of
they're
ecosystems.
very, so sometimes they are, but
Come on.
we're talking about invasive ones, right?
Okay.
So
Feral hogs.
not wild boars that are part of the historic
Right.
ecosystem,
Okay.
right? These are invasive animals, a lot of them hybrids.
Okay.
But they're very cute when they're tiny. When they're adults, they can actually be really dangerous. They can like dent car doors. They can send people to the hospital. They're huge. They're heavy. They have sharp teeth. They're aggressive. So there's lots of concerns there. I know also they can like get into people's campsites and completely ruin their campsites, right? So that's generally the expectation. However, I wanted to bring this story because it's really interesting. This is a kind of a weird reversal, because they looked at 68,000 forest plots and then all across the United States, and combined the plots, the information on the plots with like the native and non-native plant species found there, with data from Snapshot US 2021, which is the largest annual national mammal camera trap survey in the United States. So camera trap information with these forest plots. And what they found was that the deer actually had less native plants than the boars and pigs. That's because deer are selective feeders. They prefer certain species, which are the local species. The pigs will eat anything. They are rooting through the soil. They are eating whatever plants. They are eating other food sources. And so what they found was that actually the space with deer had more invasive plants, greater invasive plant diversity. The areas with the pigs had fewer invasive plant species and greater numbers of local plants. The best explanation for this is that their rooting behavior and their broad diet created a disadvantage for invasive plants, but that, the native plants were able to cope with it. So this obviously bucks the expectation that the native animal would be better for the ecosystem. In this case, if you're looking strictly at native plant species, the boars were better. Now, this is also added on, right, that a lot of these areas don't have the historic predator to deer. So that's another piece, is that the deer don't have natural predator pressure, and so they're able to kind of eat their local native species however they want. Just a reminder that there's a more nuanced discussion that needs to take place here about biodiversity, ecosystem management, and that inherently a species' impact on ecosystems does not depend on whether it's native or non-native, but what it does in nature. This was hard words for me to read, because generally speaking, this is one of my things, right? Is I'd rather have the native than the non-native in a space. They were adapted over thousands or millions of years to live in that space amongst those other plants and animals. But if you take a second and you recognize how much we've really messed with everything, there's a lot of other variables at play. We already changed everything. So, before you worry about burning all these resources on eradicating wild pigs, if you're really just worried about the native plants, maybe it's okay. Ooh, I lost Kiki. That's interesting. I'm sure she'll be back. I'm going to move on to my next story, unless anyone in the chat room... Oh, okay. Why do we try to maintain ecosystems and fauna? Well, we could talk for 6 hours about that. Ultimately, ecosystems, plants and animals within an ecosystem interact. And those ecosystems interact with other ecosystems. And it's not to say that we don't want anything to change, but it's more that the time it takes for the planet and associated ecosystems and biomes and all these sorts of things to adapt to new variables, to new plants, to new animals, to new climates, it takes time. And unless you're curating it all, like it's a zoo exhibit or a garden, then you want it all to kind of interact in a way that is harmonious and balanced. Like there needs to be a balance in the energy that flows through a space, right? So in order for that all to happen, then you can't upset things too dramatically too quickly. So I think that would be my argument for why ultimately you want to keep ecosystems like they are, is because you're trying to maintain the balance of energy flow in a space. Because if you completely upset that, then you're likely to have what is essentially ecosystem collapse. And yes, it will come back. But it's this kind of larger conversation about like the planet's not going anywhere. How habitable it is for us and other plants and animals. That's the question, right? So it's part of just a larger conversation about not wanting to fully upset the apple cart of entire ecosystems.
It depends on whether or not people like apples.
Yeah.
Whether they like upsetting apple carts, I don't know. Generally, I think it's a poor idea.
Yeah. Generally, you want the apple cart erect.
Let's keep the apple cart upright, everybody.
Yeah.
Let's keep going.
Yeah. All right. Do you want to hear about pigeons?
Blair, you know I do.
Okay.
Yes.
How many times do you think we've talked about pigeons? I should have looked this up. I've probably...
So many.
From brief mentions, many times, dozens, I'd assume. But I would wager, I should look this up later, but I would wager I've probably done between 8 and 10 stories in the time that I have been on this show about how pigeons navigate. And I just love that every single time the article is basically like, no, we were wrong. Gather round because we figured it out.
It's new. This is
It's
different.
new. Everyone else was wrong before. And this is the answer.
I know.
Is like the narrative every time. Now, this one, I must tell you, is out of left field. And that is why I brought it. Because it's not just the like, it's their ears. It's not their ears. It's the ears. It's not the ears. That's been a lot of them, right?
No, but it was the eyes.
And then it was the eyes. And then it was it was in the brain. And
then it's these quantum first it was iron particles. And then it's quantum mechanics. And okay.
Uh-huh.
Okay.
Well, guess what it is now, Kiki?
What?
It's their liver.
Why? Claire. Okay.
A new study published in Science.
I'm just gonna nope.
Yes.
Just, when you think of bird liver, you immediately think foie gras, right?
I mean, I don't, but you sure? I've never had it. Isn't that what pate is too? Is goose liver?
Yes, it's liver.
Yeah.
Yes, so if you're eating chicken pate
or
whatever, it's
you're
liver.
Getting your iron, is what I'm here to tell you.
You're getting your iron because that's where the iron is.
Yeah.
But
yeah.
Oh, this is the iron particle connection.
Yes.
Between the eyes and the liver.
Yes.
Okay, I'm getting ahead of your story.
Yes.
But
no, that's okay.
My big question is, have we been eating the organ for navigation for these animals?
Yeah. Maybe. All I can say is maybe at this point.
We thought it was just filtering the blood, but no.
Yes. Well, okay.
No.
So now they're saying there's specialized cells in the liver of pigeons that can sense the Earth's magnetic field, which gives them an internal compass. Now, I will say there's some interesting actual experimental pieces to this story, which make me not completely think it's BS. So I actually want to get into it.
It's published in Science. It can't be BS. Claire.
Right.
Which is not true. I want everyone to know that studies have been retracted from Science.
Oh my God. So there's macrophages in their livers. There's macrophages are immune cells. They break down red blood cells. Of course, red blood cells full of iron. So they accumulate iron, and this gives them the, quote, quantum properties that may allow them to respond to magnetic fields. And so, all right, here's what they did. So, I have to, okay. I'm finding the actual study design. Here we go. I appreciate it. They used techniques known as vibrating sample
magnetometers?
Yes, magnetometry. Yes. That's what I was having trouble saying. And magnetic cell separation to screen organs that they thought had to do with magnetic sensing. They looked at the eyes, they looked at the beak, they looked at the brain, and then they also looked at the liver and the spleen. They had some clues that the liver and the spleen had magnetic properties because they break down red blood cells. That's a lot of iron. Then they examined all the tissues. The liver showed the highest concentration of iron. Also not surprising. Moving on. The iron is crystallized into oxide nanoparticles, which makes the cells super paramagnetic and reactive to magnetic fields. So then they looked at the macrophages in the liver and found that they were responsible for the response to the magnetic field. Then, to test if the liver macrophages played a role in navigation, they conducted experiments on pigeons that were trained to return from distances over 20 kilometers back to their aviary in Germany. They removed the macrophages, and then pigeons lost their sense of direction on overcast days.
What?
But when the sun was visible, they were able to find their way home using solar cues.
Wait, what?
So by doing that, they think that means for sure the macrophages in the liver are giving them the magnetic sensing abilities for navigation.
What?
Yeah. Then they looked at how the signals from the liver might be relayed They looked at electron microscopy. They showed that the iron-rich macrophages sit close to nerve fibers, which suggests that there's a pathway for magnetic information to reach the brain directly from the liver.
What?
And so this is the okay. Here's the. I'm bringing it home.
Blair, I am.
I'm bringing it home. Are you ready? They believe that the pigeon experiences this as a gut feeling.
No.
So this is their gut feeling of where to go, is because the liver is telling them.
Oh my gosh. Well, I mean, there's been the conversation because of the iron particles that are quantumly activated within the visual system of the pigeon and other navigational migratory birds, that they've said it's like could be because they don't know, it could be like a glow in their visual field.
Right. I remember this, yes.
So now maybe it's a glow in their visual field. And maybe it's just their liver telling them where to go.
Well, I liked that they were able to actually experiment and see if the pigeons could find their way home without the macrophages. So I thought that was neat.
I mean, that's incredible. I mean, that whole thing.
I don't quite understand. I feel like I need hours to understand how.
Why? They don't understand how. They just found something that when they removed it, it was correlated with a loss of ability. That does not mean that they themselves are part of that signaling path. I mean, they're part of the signaling pathway in a way, but we don't know what part of the pathway they are. So the macrophages could be a limb, right? But it's enough of a limb to completely disrupt the pathway. But
yeah, good point. I'm glad you brought that up. That's totally true.
What?
But I like to think it's the liver. That's hilarious to me. It's like full of iron.
Liver's the food that your dad gives you with bacon and ketchup and onions when you're growing up poor in the country, and you're like, why do I have to eat this? It's disgusting. And your dad's like, yeah, it is disgusting. It's just your body's filtration organ, and that's all. But
Meanwhile, I'm thinking about how I've been giving my kid the Gerber oatmeal, which I'm sure you remember that there was this viral thing that it was full of iron, and people were taking magnets and being like, look at all this metal in this oatmeal.
Oh, I've done that experiment. It's so fun. But I did it with the actual the flake breakfast cereal, and it's really awesome, but it's a different kind of iron.
Yes. Well, and everybody was like,
iron.
Everyone was like, this is poison. It's like, no, dude, it's fortified with iron. Can you read?
Now, people can read, but they don't know. So we have to help them understand that this is not a bad thing, and the people on the social medias are telling them stupidity.
Sensation. Meanwhile, hey, birds navigate with their liver. How's that for sensation?
What?
Yeah, that's what I have for the animal corner today. You're
Blair,
welcome.
I'm not coming back from this one.
It's fine.
I have two great stories to follow you up, but
yeah,
I am extending the animal corner.
Yes, bring me bowerbirds because I have not heard about them in so long, and I love them so much.
I love the bowerbirds. Okay, so anyway, there's beautiful pictures in this pigeon study. We've really
pigeon livers.
Pigeon livers. Don't eat foie gras unless you really like it and you're French.
Well, and also maybe don't, because I think it's pretty terrible how they make it. But
that's just, eat your ultra processed food if you want. I mean, I mean
how it is for the animals in the process.
I know it is like ultra bad processing of animals. Terrible. Okay. Moving along. Bowerbirds.
Yes. Yes.
We
Yes.
have heard a
Yes.
lot about the blue bowerbird. I believe David Attenborough, a couple of decades ago, before he recently turned 100, a couple decades ago, in a documentary, he talked about the blue bowerbirds and how the male of the species will find blue items with which to treat the female of his species to a special date. He will build a bower. I don't know what the words he said, but anyway,
Well,
the
my
bowerbird.
favorite thing about the
Yes.
bowerbird is
They
that
build a bower.
they
like
build a
big
bower, but it
thing out of
was
sticks.
very early on in my run in the show. I brought a story about how they actually
Yeah.
use size to their advantage to make, I think it was to make them look bigger. Or to make the bower look bigger. I can't remember.
Yes.
But they
So
basically
they
use like
have-
optical illusion.
Yes, so there's an area around the bower that they've made so that when the mate sees them with perspective. So if you've ever gone to the city and they have, you know, the artists that do the weird perspective chalk drawings on the sidewalk where, oh no, I'm going to fall into a pit. You know, no, you're not. It's just a chalk drawing on the sidewalk. But because of the use of perspective, and the bowerbirds do that same thing. And that's the story that you were talking about back then. And so the bower looks huge. And they look huge, but it's all about where they place themselves and those little, not just the bower. The other aspect to the bower is it's decorated.
Mm-hmm.
So they build a structure for their love. And around it, they place gifts. The blue bowerbird is more likely to choose blue items.
Mm-hmm.
Yes. The blue bowerbird loves blue, loves all sorts of blue things, whatever. Bowerbirds in general, though, the species, they have this bower habit. And they grab all sorts of stuff. And this study, published in Royal Society Open Science, looked at the bowerbirds, city birds versus country birds in Australia. So the study is University of Exeter, and they looked at items collected by bowerbirds in Townsville City and a rural area in Queensland, both of them in Queensland, Australia. And so they were looking specifically at these bowers that are built by the males of the species and what the males like to grab. What do they like to pay attention to? And so in this study, they have a whole bunch of sites. Really, the idea is because they're grabbing all sorts of stuff, a lot of it is human trash or just human awful. And so what are they grabbing? Is it more likely to be grabbed if it's human in origin or not? Where does it come from? And the researchers in this study, they basically published and they said city birds pretty much only use human stuff. The rural birds, of course, they like to use, all of them use whatever they can get their hands on to create their bowers. But the rural birds, if there is no human stuff nearby, the rural birds are going to grab mostly green leaves, green bits of grass, like lots of nice green colored things, other colored things they can find. But if they can find other colors and other decorations, they will look for them. And so, of course, the urban environment has more colors and more fancy, shiny things. And so you find more colors being used within the urban environment than in the rural environment. Moving on from there, the researchers were like, okay, what are they using? Well, in the urban sites, they use a lot more red. There's a lot more red in what they find. But beyond that, they found that those birds really, really like shiny human things.
Shiny!
Like basically The shinier, the better.
So plastic, basically.
Plastic.
Yeah.
In one instance, they actually found the bowerbirds had found and were tossing around handcuffs. So it doesn't have to be plastic. Shiny is really great. They love shiny, but colorful. And so because of the colors, they definitely use a lot of red materials, or a lot of green materials, but red is more of a choice. And so I think this is really interesting, especially they didn't look at the blue bowerbirds, which have focused specifically on that color blue, and so this is really interesting, just trying to figure out the influence of the environment on the choices that these birds are making. And what they're finding is that they'll throw a scrunchie at a prospective mate. They'll throw a pair of handcuffs. Look at my little red bits and bobs. Look at this beautiful bower I made for you. Look at this piece of electrical wire.
Cute.
So urban environments actually offer a wealth of materials for these bower males to use to seduce the females.
Oh, the microplastics.
Right. I mean, but that is, I guess, a bit of an issue, kind of, because it's not really until they become super micro until they get stuck in somebody's gut that they're really a problem, right?
Yeah. It's interesting, the red, I think, because it's the opposite of the color spectrum from green, right? So, it would potentially stand out the best in a natural environment.
Yes, which is green or brownish, right? And so the red is going to be, like you said, like much more visible. And so I think that is, indicative of the use in the urban environment. And they did say that in the rural environment, if the rural birds got their beaks on somebody's trash, that they would look through it and they would take out the more colorful bits and pieces.
Nice.
And so human trash, it's not necessarily bad for these birds in this situation, but this is another example of how we are influencing the behaviors and activities of the animals around us. And this one is very visible because of the colors being used. I can't wait to meet that one bowerbird who found a pair of handcuffs.
Were they red handcuffs?
No, red. They were like shiny silver handcuffs.
Sure they weren't red fuzzy ones?
Exactly. Little fuzzy from a store. And my final story for tonight.
Yes.
Yes. Has to do with Dartmouth octopuses.
Okay.
Yes. Okay, so this study out of Dartmouth University is something I think that you will love. Is published in Current Biology, and it was just published. Researchers, we talked about the beluga whales last week and the mirror test. This is not a mirror test.
Okay.
But it is a mirror test.
Okay.
So in this study, researchers put mirrors in the octopus habitats. Let them play with them, whatever. Figure out that, okay, this mirror is not me. They taught them what a mirror is for. And so they started putting fake crabs behind the octopuses, the activities, put the fake crabs behind them because the octopus hunts using scent. And so this mirror test would not work at all if it were a real crab. So fake crab trained the octopus to understand, if I go for the fake crab, I will get a real crab. So there is a treat involved.
Crab treat.
Yes. So mirror in front of the octopus looking into the mirror, fake crab behind the octopus. reflected in the mirror so that the octopus could see it. 73% of the time, the octopuses turned around and went for the fake crab to get the real crab treat. The researchers and did not attack the crab in the mirror.
Mm-hmm. That
They
sounds like the mirror test.
Right. They
Sounds
didn't
very similar,
they
yeah.
didn't interact with themselves.
Mm.
They understood that the object in the mirror was not really the object, but a representation of the object as
Mhm.
reflected from behind them. So the study, what they're highlighting is cephalopods can interpret mirror reflections for spatial navigation. The octopuses got faster. So travel duration to the reward site. So how long it took them between seeing the crab, getting to the crab, it got faster. They understood that, oh yeah, okay, I see it, I get to go there and I get real crab. And so they got better at doing the task, which means that they were learning. Additionally, the octopuses climbed a barrier that was put between them and the fake crab so that they didn't go directly to the fake crab. They actually went up and over a barrier to get to the fake crab because that was actually the faster route.
Hmm.
And so the what they're suggesting is that the octopuses in their spatial navigation are, not just focused on the reward, but they understand the layouts of the spatial aspects of their tank. They understand how to navigate it, and they understand that reverse impact of the reflection. Like they were able to learn what a reflection means. Yeah. Anyway, they suggest these abilities might reflect convergent evolution of spatial cognition, because this is the interesting thing, right? How far separated from any other animal that we have. I don't know. I think this is the weird one. Spatial cognition. So how do we, what aspect of spatial cognition? Because, mammals can navigate spatial environments. They have cognition, planning, aspects of understanding the environment, but so do birds, so do reptiles, so how far back do we go?
Yeah, this feels a little tacked on.
Yeah, that little bit at the end, I'm like,
Yeah.
well, yeah. But what do you think,
Well, we're
Blair?
at it. Octopuses are really smart. This is not that surprising to me, but it's really cool, I would say. I think that also because, a reminder that octopuses can match their environment both texturally and visually. They can make it through puzzles. They can remember things about a puzzle space. So we know there's lots of spatial awareness already. And I think that it makes sense that they'd be able to, first of all, they have complex eyes, right? So they can they can just basically see very well. But they also have to understand how their placement relates to other things that they see, because they have to adjust their body so much to camouflage, but also to move through spaces.
I imagine the way that birds must have spatial cognition because of the fact that they fly, right? The way that they understand space is inherently different than the way that we understand space. And I think the same thing can be said on an entirely different level about the octopus, because of the way that its body inhabits space. It probably has a spatial cognition, 3-dimensional, 4-dimensional, similar to us, at least in a evolutionary context. But I wonder how different it is based on the contortions that their body can undergo.
Who was it? What animal was it that they did through an AI trying to figure out if it would be able to fly, even though it's an animal that doesn't fly naturally? Do you remember that?
Oh, yeah, no.
That was
Well,
a
they
couple
tried.
weeks ago.
Right. That was one where they were that let's simulate a fly brain. A worm, wasn't it?
It was a worm. It was a worm.
Yeah.
Yes. So
Yes, and
I
they're
was
like,
thinking
a worm
about this
can fly.
because I also was
like,
recently
all
having
right.
a very heated debate with Brian, my husband, about if people always are picking like which superpower you wish that you had, like that classic question, if you could have any superpower, what would you have? And a lot of people pick flight. And I was like, well, I feel like our brain wouldn't be able to handle that because it's like, and then we got back into this whole thing that you and I were talking about with the worm, because it does your brain hold the capacity to handle the spatial information needed to be able to fly in 3 dimensions. Like, that's tough stuff. But I think that
the worm did.
Yeah,
apparently.
the worm did. So you know what? Maybe humans could. But yeah, the octopus has to move through space in 3 dimensions. They have to change the shape and size of their body. They have to change the texture of their body. They have to change the color of their body. They have to squeeze through spaces. They have to use their tentacles or their arms to feel, to retrieve food. Like, there's all this sorts of crazy stuff that they do that requires command of a space in a way that we can't even begin to imagine, I think. But it's more just like remember, there was an octopus that was smart enough that figured out that they could use their siphon to spray water to short out an electrical panel to escape. So like, octopuses understand
a
long series of cause and effect. So all they would need to do is look at this mirror, move their body a little bit, see how their movement moved in the mirror, and go, okay, this follows this particular rule set for movement. Therefore, that thing that I see in there is here. So I think that it's a perfectly reasonable expectation that they could, but that doesn't mean that this study isn't also super interesting and it also needed to be done.
Yes, exactly. Like, so many studies were like, oh, okay, finally somebody did that. Okay, duh. But at the same time, this one, I think it's important in the process of that understanding.
Yeah, I would argue this is less of a duh and more of a, oh yeah, that makes sense.
Of course. Yeah. Okay.
Oh yeah, that tracks.
Yeah. Anyway, octopuses, they can use mirrors.
Ugh, I love it.
So that's going to be fun at museums from now on.
Yeah.
Have we done it?
We've done it. It's time for bed.
Yeah, we made it to the end of another episode of This Week in Science. So much fun. I loved having so many good animal corner stories tonight. That was fun. It's fun playing Animal Corner.
Now for the whole family.
Yeah, fun for the whole family. Animal corners are great until you have, what was it? Traumatic insemination.
Oh my, that's a blast from the past. Haven't talked about that in a while.
Obviously, you haven't found any studies recently that have brought it out. So
I definitely would have.
I think science is lacking. Apparently.
Yeah. I wonder if that would get a study flagged by the current administration.
Oh man. I hope not, because that's just good science. Gotta tell you. Oh, it's time for some shout outs. Thank you everyone for being here for another episode. It's always so great to be here and talk with Blair, but at the same time talk with all of you in the chat room, and to be able to know that you're listening and that we're having a conversation, that we're all in here together. So thank you for being in the chat rooms. Thank you for conversing. Thank you, Radius, for that donation during the show. Absolutely, absolutely appreciated. And thank you to a few people who are very, very special to the show. Fada, thank you so much for all your work on social media and show notes every week. Cannot do this without you. The work you do, it just helps so much. Identity 4, thank you for recording the show. Gord, Arnlore, others who helped to keep all of our chat rooms like really great places to be. You moderators, you're amazing. Thank you so much. And Rachel, thank you for editing the show. And to all our Patreon sponsors, thank you for being our patrons. Thank you, Aaron Anathema, Adam Mishkan, Alan Viola, Ali Swan, I can't even speak, Ellie Coffin, Andrew Swanson, Artem, Arthur Kepler, Bob Calder, Bob Coles, Brendan Minish, Brian Carrington, Chris Wozniak, Christopher Dreyer, Christopher Rappin, Craig Landon, Craig Potts, Daryl Myshax, Dave Wilkinson, David E. Youngblood, Don Mundis, E.O., Eden Mundell, Eric Knapp, Flying Out, Fredis Winoflord, G. Burton Lattimore, Greg Briggs, Jack, Jason Olds, John Atwood, John McKee, John Ratnaswamy, Johnny Gridley, Ken Hayes, Kent Northcote, Kevin Parachan, Kevin Reardon, Kurt Larson, Lon Makes, Lauren Gifford, Mary Gertz, Marjorie, Mark Hessenblow, Mark Jenkins, Noodles, Patrick Pecoraro, Paul Polly Disney, Paul Ronovich, Philip Shane, Pierre Velazarb, Richard Badge, Robert Norland, Robert W. Farley, Rodney Lewis, Rudy Garcia, Remy Day, Sean Clarence, Lamb, Shubru, Stephanie Embry, I think that's a new name, Stephen Alberon, Steve Leisman, a.k.a. Zima, Sue Doster, Teresa Smith, Tony Steele, and Vegard Schefstad. Thank you for supporting us on Patreon. If anyone out there, if you want to help support the show on Patreon, head over to twist.org, click on that Patreon link. And if you want me to mispronounce your name at the end of the show, make sure you are a $10 and more or more a month supporter.
And more is good.
And more. Yes, and more is always better. Yes. We always have good links at twist.org as well. But oh my gosh, Patreon is where it's at. And on next week's show,
we will be back on Wednesday at 8 p.m. Pacific time, broadcasting live from Twitch, YouTube, and Facebook channels.
And if you want to listen to us as a podcast, make sure that you look for This Week in Science wherever podcasts are found, wherever you like to find your podcasts, and get your friends to subscribe as well.
For more information on anything you've heard here today, show notes and links to stories will be available on our website. That's at www.twist.org. You can also sign up for our newsletter,
which will come out someday because I really think about it a lot. Like on a weekly basis, daily basis even, I think about it. Oh, we love your feedback. If there's a topic that you'd like us to cover or address or a suggestion for an interview, please let us know on one of our social media channels or send us an email. Just put TWIS in the subject line so your email doesn't get spam filtered into where, Blair?
Episode of This Week in Science from April 2012 when I first talked about magnetic fields. There were over 25 episodes about magnetic fields that we have talked about.
That's amazing.
Yeah. So it'll go all the way back in time. There. Unless you label it properly. Put TWIS in the subject line. And we look forward to discussing science with you again next week. If you've learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.